Good evening and welcome everyone. Hope all of you are well and had a great festival season. My name is Yogesh and today I am here with another webinar on Mars Orbiter mission. Just let me know before starting that whether I am audible and visible or not so that I can move further. Yeah, great. So I'm audible and I welcome all of you to our next webinar. And this time the webinar is on our own Indian mission that is also known as the Pride of the India, the only mission that India has sent to any other planet. That is Mars Orbiter mission, or in short it is known as MOM. So today what we are going to learn, what we are going to understand is what was this mission all about, how it all started, what was the need to send a mission to Mars, what this mission has achieved, what are the different parts of this mission, what were the objectives of this mission, what all challenges were faced by ISRO scientists. So it is going to be like a kind of story, right? And I'll try to make it as interesting as possible. Though many of us we have already learned about the story of Mars Orbiter mission, well portrayed in a movie, Mission Mangal, right? So yes, in that also the story was there, but Bollywood movie, right? So there may be some twist of facts, right? So let's start with the today's session and let's understand the whole mission in detail, right? So let me share my presentation. Hope you all are able to see the welcome screen. Now, talking about Mars Orbiter mission. So, when we are talking about Mars Orbiter mission, right, you must have understood one thing, that it's a mission that was sent to Mars. And second thing that we need to understand from here is it's a kind of orbiter. Now, again, I'm saying Mars orbiter, then I'm saying mission. So, what does the term mission means? And before moving ahead, I want to talk about this timeline, but before that, let's understand what a mission is. So, when you talk about a mission is a certain kind of task that you are supposed to complete, right? That means it's like that you have to go out in the ground, pick up 10 stones, and come back. So, that will be a sort of mission where you have to go at some place, okay, do some task, give us back the result. Now missions can be of many types. Four types are written over here. These are the four common types. Okay, first one is a flyby mission. So in a flyby mission, what happens? We send up a machine. It can be a satellite, it can be a camera, it can be any other thing, which goes near to a planet. Let's say this is a planet, okay, which goes near to a planet, clicks its photo, tuck 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 tuck, and move forward. So what it is doing is it is just clicking the pictures of that particular planet. So it can study the surface details of that planet, right? But the point is, what if we need more data? So in case of flyby mission, we need to send another mission. Came up with the next idea that instead of just flying by, what we can do, we can go to that planet or that celestial body and start orbiting around it, right? So orbiter mission, in that a spacecraft goes around a planet, moves around it, keeps on collecting the data day and night, right? And stands there for a longer time, like 3 months, 4 months, 10 months, 12 months, years, right? And collects up the data. Next, we move a step further, that is lander, right? What we do, we send a machine that lands onto that celestial body, do some experiment over there with the help of robotic arms or anything, or in the way that they were supposed to be, not necessary that they have robotic arms. Last one is the rover, the most advanced one, where the machine can move from one place to another, right? So four different types of mission: flyby, orbiter, lander, and rover. Now, one thing is clear that this MOM is an orbiter mission, right? Is an orbiter mission. Now, let me take you on to a timeline, right? So, because if we want to talk about this Mars orbiter mission, the timeline is very important. So, let's start from 1969, the time when the ISRO was getting formed. So, at by that time, NASA has reached to the moon, Russia has reached to the moon, India was just starting, ISRO was just established, and we were making missiles. We didn't had a own rocket as well, but soon we got our first rocket, the sounding rockets in 1980s, all thanks to Abdul Kalam sir. Now, after that, what happened? India started making the rockets. Then India made its own, or India made its first satellite in 1975, Aryabhatta, right? Then what happened? After that, we started making many more satellites. Slowly and slowly, we developed bigger rockets. We developed PSLV. Then we thought of going out of the orbit. We thought of going out of the Earth. Earth, in the sense, we had to leave the gravitational influence of Earth. So we thought of sending a mission to Moon. So Chandrayaan 1, successful mission. We sent an orbiter which is still which orbited the moon, right? Gave us the data and also helped in finding the water on moon. But what's the next step? Where we should go next? So here comes the question. Now there was a trend. The trend is simple, that first you develop your rocket, second you launch your satellite, third you go to your nearest neighbor moon, and the next step in that is do an interplanetary mission. Now when I say interplanetary, means you have to go to some other planet. What are the options? Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. We can choose anyone, right? Where will you like to go? You might say, Sir Saturn, Sir Uranus, Sir Neptune, Sir Mercury, Sir Venus. But the question will come, do you have that technology? So here comes the answer. India at that time had developed the technology to reach the moon. But we didn't have any technology to go on any of the planet. So there was a need. And when the need is there, at that time ISRO came up, ISRO said, okay, we'll take up this challenge and we'll reach Mars. We'll go to Mars. Now, so in 2008, Chandrayaan 1 was successfully launched, and that was launched in January or February, I guess, in the starting of 2008. And by November, an interplanetary mission was declared by ISRO, 23rd November 2008. So uncrewed mission to Mars was announced by then former director of ISRO, that was Mr. Nair. Now, what happened? The team started working on this, right, in that mission from 2008. By 2010, that feasibility test was conducted by Indian Institute of Space Science Technology. Now, what they do in this test means, where do we have the technology that we can go to Mars or not, or what are things needs to be done? A kind of prototype, you can say, has to be made and has to be presented in front of the government. 2012, the mission was approved by the former Prime Minister Dr. Manmohan Singh. That was date was 3rd of August. And by that time, ISRO has spent nearly 100 crore rupees on that mission, on working on the orbiter, because we were also working side by side. ISRO was also working on Chandrayaan 2, right? Now, what happened? They thought, okay, 2012, they got the mission approval, and the next thing was, next problem was, or the next challenge was, see, if we have to go to Mars, we have two options. One option is we have a huge bulky rocket and we take a lot and lot of fuel, spend a lot of amount, right, and we go directly to the Mars. But again, ISRO is known for its innovation. They said no. They said, means at that time ISRO was checking their GSLV rockets. The first launch failed. Okay, so we couldn't use that Bahubali rocket. At that time, the second rocket on the second number was PSLV, and going to Mars from that PSLV rocket was not possible. Second thing, it didn't have that much capacity that it can take up thousands of kilograms of weight. Now, at that time, miniaturization was done in Mars orbiter mission. lot many you can say innovations were done by ISRO, and this whole Mars orbiter mission was miniaturized into a compact packet. Though even after doing miniaturization, it weighted more than 1300 kilogram, but it was okay, and that can be lifted up by PSLV. Now, if you have to go to Mars, then there are certain launch windows, there are certain dates, and those dates, they or that appropriate time comes once in every 2.5 year. Okay, now in the whole world, in the world, NASA was also working at that time to send the Maven mission. Okay, MAVEN, Maven mission to Mars. Now at that time, India had chance, right, that we can reach to Mars in our first attempt before, and we can launch before Maven. So only 15 months were left after 2012. Only 15 months were left, and the best time was in October, November. There was a launch window in October and November of 2013 because mission got approval in 2012. 15 months, scientists had to work. Now, if I talk about one more mission, as I said, Maven mission was sent. It took 5 years for that Maven mission, but it took only 15 months for the scientists of ISRO to work completely on this Mars orbiter mission. Why? See, here comes the enthusiasm of Indians, right? The group who was working on the ISRO on that Mars orbiter mission had a good mixture of young people and experienced people. So they worked for more than 18-19 hours each day, right? Put up their extra efforts, and it was all set to launch in 28th of October. But we had to delay, okay, we had to delay intentionally by 7 days because two of the ships who were supposed to reach at their designated place in the oceans to receive the signal from the Mars orbiter mission, they didn't reach their place. So we waited for 7 days. On 5th of November, Mars orbiter mission was finally launched, and India took pride in launching the first interplanetary mission. Things were very good for next 9 months when Mars orbiter mission was on its path, or almost 10 months. Mars orbiter mission was on its path towards the Mars. But again, the main challenge was to successfully enter into the Martian orbit, right? So that challenge was completed in 2014 on 24th of September, and since then, Mangalyaan, or the Mars orbiter mission, or the MOM, is encircling the red planet Mars, right? So again, a very interesting story, but we'll discover more about this Mars orbiter mission in our upcoming slides. So let's talk about it. When I talk about a mission, I said it's a type of what type of mission is this? It's an orbiter. Okay. Now, when I'm saying orbiter, again, it must be orbiting the Mars. So what is its orbit? See, you can see the picture on the right hand side. Its orbit is elliptical. It's not circular. Second thing, again, Mars is not in the center, right? Mars is towards one of the sides. So there are 2 points. One is periapsis. That means how close the mission will get. Let's say this hand is Mars. So if MOM is taking this orbit, so the closest point of the Mars orbiter mission from the Mars is 421 kilometers, and the farthest point is 76,993 kilometers. Its orbit is so huge that it takes almost 3 days, 51 minutes and few seconds, as written over here. You can see, right? So this is the time period that this Mangalyaan takes to complete one round around the Mars, because its orbit is so huge. Now, talking about the payloads. Okay, so when I'm sending an orbiter, that means that I also have to do some experiments, right? And what are experiments were supposed to perform? So if I wish to do any of the experiment, then the point is, how will I do the experiment? For that, I need some material, I need some instruments with me. Okay, so for that I sent some payloads. Now, what are payloads? So payload can be anything that is sent with a mission. It can be astronaut, it can be let's say machinery, it can be the if you wish to do the experiment, then it is your equipment. So we sent 5 payloads in total with the Mars orbiter mission. First one is the Mars color camera. Right, so as the name itself suggests, Mars color camera, it took the pictures of Mars in the color, and the camera was built to take the pictures of the Martian surface. It takes a picture in 3 colors. Then comes um, thermal infrared imaging spectrometer, that is TIS. So TIS measures the thermal radiation emitted or reflected by the various minerals from the surface of Mars, right? And can be operated during both day and night. It helps the scientist to study and understand the minerals on the surface of Mars. Then came the next instrument, that is MENCA, which is on the bottom left corner, right? Which is like, it's an acronym for Mars Exospheric Neutral Composition Analyzer. What does it do? Again, it is used to study the neutral atoms in the outer atmosphere of Mars. Means the five instrument, out of the five instrument, two instrument were sent to study the surface, three instrument were sent to study the atmosphere. So this MENCA was sent to study the neutral atoms in the outer atmosphere of Mars. It helps to understand most of the thick atmosphere. Means on Mars there is some atmosphere, right? So to understand how most of the thick atmosphere of Mars has what do we call it? It has escaped. Right, nowadays the atmosphere of Mars is very thin. But it's said that in the ancient time, once Mars had a very thick atmosphere. So where it has gone? This is an instrument to find out that. Then comes the next instrument, lab. It's a kind of photometer, Lyman alpha photometer, right? So it helps the scientists to understand how water was lost from Mars, right? Just like I said, it had an atmosphere. It's also said that Mars had water in the ancient time. How we can say that? I'll show you some pictures of that. Okay, but yes, it said that. Then comes the last instrument, methane sensor for Mars. So it is designed to measure the methane gas present in the thin atmosphere, right? And to identify the source of this methane. Because the methane gas is present, that means there are some signs of life as well. There can be some signs of life as well, right? So that's why they are so eager to detect the methane, right? So these are the 5 major instruments sent with the Mars orbiter mission. Now if a mission is there, that means it will be having some objectives, right? If a mission is there, that means it will be having some objectives. So when we talk about objectives, the objectives of this Mars mission were divided into two parts. First one, technological objectives, and second one was the scientific objectives. Let me just simplify it. What? Okay, just give me a second, students. Okay, so there is some issue with my camera. Just give me a second. I'm just fixing it and let's start again. Okay, I hope I am visible again. Right Now, so talking about the technological objectives, right? So there are two kinds of objectives, as I said. First is the testing of technology. See, ISRO was developing new technology, and second thing was scientific objective. See, whenever a mission is sent, we have to perform certain tasks. So technological objective means what technology we want to achieve from this particular mission. Scientific objective means what science we want to derive. So technological objectives were simple, that we want to design and send an orbiter that can go to Mars, that has the capability to reach Mars, travel in the space for more than nearly 900 days, right? And then it can withstand the harsh environment of space. Then comes it can do the deep space communication. See, deep space communication means, see, when I talk about the satellites are very near to the Earth, like in an orbit of 100 kilometer, 200 kilometer, or max to max 36,000 kilometers. Okay, but when I talk about the distance of Mars is at a distance of 75 million kilometers, right? Too far. So, to establish the communication with all such spacecraft which are so far away, we have a kind of network system here on Earth known as deep space network. Right? So can we develop a system, or can we develop an orbiter that can communicate with that system? Autonomous features. See, you cannot if a okay, let me give you a stat. If you go with the speed of light, you will take nearly 15 minutes to reach on Mars. Or let's say if you send a signal to Mars, it will take nearly 15 minutes for that signal to reach there. Now, just suppose that Mars orbiter mission, it reaches to Mars, something happens, right? Something happens into that orbiter. So it is going to take 15 minutes for that signal to reach us, and again some time for us to resolve that issue. Again, more 15 more minutes for that signal to go from here to Mars. So this will cause an error. To avoid that, all the missions, they have to be designed in a way that if there are any small issues, they can handle that or correct those issues themselves. Same thing you must have seen if you have seen the movie Mission Mangal, that there was some time when Mars was behind. The Mars orbiter mission was behind the Mars, right? So it's like if there were anything that happens to that, there was a communication block out at that time. So if anything happens to that mission, we are not going to get any input for that. So we have to take care of that part, right? So autonomous features have to be designed. Next part, scientific objectives. We need to explore the Martian surface feature. Since we were not landing on the Mars, we were not expecting much. We said that okay, we are just going to observe the atmosphere of the Mars and the surface of the Mars. So exploration of the Martian surface feature was the scientific objective for us. Right? Two objectives clear: technological objective, scientific objective. And with this, okay, with this scientists designed the whole mission. Now, to understand the challenges that had happened, okay, let's first understand the path of the Mars orbiter mission, because the challenges will be covered in this. Right, so we have to divide the complete path into three parts. Okay, so part one over here is this, that is geocentric phase. Part two is over here, heliocentric phase, and part three is simple, when you will reach the Mars. Now, as I said, there's always a time period of a few months, or there's always a launch window, right? That comes after every 2.5 years. Okay, and what happens in that 2.5 years? Why only 2.5 years? This happens because of the motion of the Earth and Mars in their respective orbit. So after every 2.5 years, there's a configuration that at that time we have to travel a minimum distance to reach Mars from the Earth, right? Now, this thing is known as Hohmann transfer. Okay, in terms of orbit, it's known as Hohmann transfer. Okay, now here what we have to do is we have to plan the launching of our spacecraft in a way that we can leave it at one particular date so that it reaches the Mars by covering the least distance. So if you look at the animation which is on the right side of the screen, you will see very carefully at first that mission was going around the Earth, but after coming to a point, right, we left that mission, that Mars orbiter mission, it left the Earth and went to Mars. So first phase is the geocentric phase where it had to see. I told you in the starting, GSLV was failed before the launch of this Mars orbiter mission. We had to rely on the most reliable launcher that we had, the most reliable rocket that we have, PSLV. Now, PSLV does not have enough power that it can put the rocket or put this Mars orbiter directly into the spacecraft trajectory orbit. Now, what is that? To reach the orbit of Mars, we need to cross the sphere of influence of Earth, and for that we have to travel more than 93,000 kilometers, right? If we travel that way by PSLV, all our fuel will be burnt and we will never reach Mars. So India played a smart move. What they did, okay, they started from Earth, launched the PSLV. PSLV was put up in one orbit. Okay, after that, after some time, when it reached near the Earth, it's now because the gravity of the Earth, its speed will automatically increase. We will start a rocket engine again. Now the two components will add up. Because of gravity, the speed has increased and we will start the rocket engine. It will move with a higher speed. Now, if it will move with a higher speed, the ellipse will become bigger and bigger and bigger. Now, after some time, it will gain enough speed that can easily cross that sphere of influence. Right? So, this took us almost, see, it was launched on 5th of November. It took us almost a month to cross that sphere of influence of Earth. Before that, we had to launch 6 times. We have to fire that engine 6 times, again and again, again and again, again and again, to make that ellipse bigger and bigger and bigger. So, to the departure on 1st of December, then we have to go around the sun. Okay, now this is the heliocentric phase. At that time, when the Mars orbital mission was launched, Earth was here, Mars is at this point. After 9 months, after 10 months, you can say, Earth will come somewhat over here, okay, and Mars will be over here since the orbit of the Mars is larger, orbit of the Mars is bigger, so it will be behind, right? Now, what has to be done is, since this rocket is moving in space, in the space there is nothing to stop it, okay, there is nothing to stop it. The next challenge was to stop that rocket in the sphere of influence of Mars. Okay, this challenge was to stop that rocket in the region of Mars. Otherwise, what is going to happen? It was in such a high speed that if you don't do anything, it will simply cross the Mars. Okay, it will simply cross the Mars. If you see this picture very carefully, the rocket will come from the top left side. Come here, it will go along the dotted line. And all the 400 crore rupees or whatever money that we have spent, right, will simply fly out in space. We cannot bring it back. So next challenge. Next challenge was simple, that we have to reduce the speed of this Mars orbital mission. Again, how we can reduce? So we need to reorient the rocket. Okay, we need to turn the rocket 180 degree and start the rocket engine. Right? And here something happened. The engines were not starting, as we might have seen in the movie, and that happened actually. The engines were not starting initially, but later on, after doing something, doing a few calculations, it started, right? And then once the rocket, once the rocket was started, so what is going to happen because of that rocket engines, starting of that rocket engine, the speed of that rocket will slow down, and Mars, because of its gravity, will catch that rocket, and then the rocket will go around in orbit of the Mars. Now, if this thing will happen, so after some time, we again have to reorient the rocket so that its solar panel can face the sun. Okay, and this thing, all this thing, that should not be done manually, it has to be done autonomously by the spacecraft itself. Okay, moreover, when The spacecraft had to do all this exercise. It was on the backside of the Mars. So all these challenges, okay, taking all of these challenges into calculation and doing everything, ISRO designed and sent the rocket, right? And successfully it was launched. So ISRO achieved a feat on that day, right, on 24th of September 2014, when it inserted into when this orbiter was inserted into the orbit around the Mars. Achievements of ISRO. That time, India became the first country to reach Mars in the first attempt. Okay, and hats off till now it's a record. Okay, and fourth, fourth country, India became the fourth country after USA, Russia, okay, and ESA to reach Mars. Cost efficient. Cost efficiency is the most important point because all the technology was indigenous. Or everything, all the payloads were made in India only. Costed us only 450 crore rupees. I said that many of the movies in Hollywood have a budget bigger than this. Indigenous technology is the most important part here. That means we develop each and everything here in India, and this give the new wings to the upcoming generation, to the people who are involved in that mission, right? And new wings to the ISRO. How? Because after this, we started dreaming of sending a lander and a rover on Chandrayaan, right? So this is it. And believe me, this was the first mission by ISRO, not the last. Okay, first interplanetary mission. We achieved so much, and yes, it's not what is Mars orbiter mission doing now. So over here, see this Mars orbiter mission. It is, I say, it's a huge machine of nearly 1300 kilograms. Right here, you can see it is having an antenna, three solar panels from which it is getting the uh, energy, and then it is having a 7 meter big antenna. 7 meter, you can imagine how big is that. So 7 foot, 7 foot big antenna. How huge is that antenna? Then comes what it has done. What it has done. So findings of M1. See this picture very carefully. It's only looking like that. It's just the colored picture of Mars. It's a very important data. Why? Because we know that the biggest volcano of the whole solar system, right, is on the Mars. So that means Mars is having some volcanoes. Now, if it is having some volcanoes, that means they must have blasted out in the past. Okay. This map shows the region where we can find that volcanic activity and where there are only deserts. So all the white region that you are seeing in this picture, the gray regions that you are seeing in this picture, they all are deserts. Okay, all the gray region in this are the deserts. It's an albedo map. Okay, it's an albedo map. What does an albedo do? Albedo means how much light from the sun is going onto the Mars and how much it is reflecting back. Right? So measurement of that, the magnitude of that reflectance of light, okay, is albedo. So over here we are getting these colors. These colors represent the region where we had some basaltic rocks, means less light is being reflected. The gray region is the area from where more light is being reflected. That means that there we are having the dust. Okay. Apart from that, you can see this 3D animation that was made by the data collected by the Mars orbiter mission. Yes, on 1 year of successful Mars mission, what happened? ISRO released a book on this. That what all things, what all data we have got. Okay, you can go on the website of ISRO and read that book. It's an amazing read. Then comes the next thing. Okay, the this is about the surface. I told you in the starting that we had few signs showing that Mars once had water, right? So when we studied the surface of Mars, we got the regions like delta, we got the regions like some valleys, some ridges were there. Okay, then some of the pictures taken by that camera MCC, right? So over here, this is one of the volcano on the Mars, right? A 3D picture of that. Then comes another picture, a region, Kesai Vallis. So kind of valley, and this kind of structure shows that because this kind of structure can only be formed where the flowing water is there. So these kind of structures show that yes, once back in the time Mars might had some water. Then comes this Gale crater. So Gale crater is that region where the Curiosity rover, the more you can say now it's the second most advanced rover sent by NASA. It had landed there in the Gale crater. It's a huge crater. Another volcano which is there on the Mars and taken by the camera, right? So this was all about the Mars orbiter mission and the story in like how many challenges ISRO have to face, right? What all India has achieved through this mission, what all data we have got, and this is just not the data. We have thousands of pictures. ISRO even released that data for the public use. Means if you wish to write any scientific paper on the basis of the data, you can write. Okay, the data was released by ISRO sometimes back. Right now, that portal is not open, but you can keep on checking that website. Many people have already written paper. There are already two papers that have been published on the data given by the Mars orbiter mission. Now, for this, I would like to say all the best. I would like to wish luck to ISRO so that because ISRO is planning to send Mars orbiter mission to as well, right? That means second Mars mission. We don't know when, it hasn't been announced, but let's see when we are going to listen any new good news from ISRO. With this, I would like to thank all of you. And yes, if you are interested in learning astronomy, join this community, iAstronomer, learn, interact with us, and yes, this was all from my side, right? Thank you everyone for joining this interaction. Now I'll be taking care of some of the doubts. So if you have any doubts, please put them in the comment box. Otherwise, this was all from my side. Okay. So there are no questions over here, right? Thank you everyone for joining. Have a good day. We'll meet with another stream some other day. Right? Have a good day. Bye everyone.